Hey, welcome back. In this short video, I want to show you how you can use a spreadsheet, something like Excel or Google Sheets, to implement Newton's method. That is, have the machine do the recursion, taking one of these values and plugging it back into the same formula to produce the next value. And of course, the idea that I'm going to show you here would be able to be, you could use an Excel spreadsheet or a Google spreadsheet to do any recursion. All right, so let's switch over. I've got my desktop ready to share here, and I'm going to show you side by side. What I've got going here is I've got the notes from our Newton's method lecture. So I'm going to be using that very first example with that cubic function. And then I've got a spreadsheet that I think you can see as well. And I'm going to show you how you can produce this table of values down here using that spreadsheet, so you don't have to do them one at a time. Okay, so I'm going to show you how to implement. It's drawn in a blue box here, the Newton's formula for this particular example. Okay, over here in my spreadsheet, I'm assuming that you're familiar with spreadsheets. You know what I mean by rows and columns. You don't need to do this, but I like to have a column that shows me like my n value, which guess number I'm on. So if I just type a few values, I could type a bunch of them, 1, 2, 3, but if you want to have it do it automatically for you, if you select those cells and then click on the bottom right corner, as soon as that cursor changes to a cross, you drag down some number of rows and it'll repeat that pattern. So maybe I'm going to drag it down to the 10th row. All right. So that's going to just be a column telling me which guess number I'm on. And now in the second column, just like with ordinary Newton's method, I have to seed the process. I have to give it a seed. I'm going to use the same seed that we did before, x equals 1. Okay. And now in the second cell in column B, I'm going to implement Newton's formula. So when you do a formula in a spreadsheet, you begin the cell with an equal sign, and then I'm going to use what are called references. In the sheet over here in the blue box, everywhere there's highlighted something in yellow, I'm never going to type a value in for that. Rather, I'm going to click a cell that contains that value, and that's called referencing that cell. So instead of starting off with a 1 here for my xn, I'm going to click this cell, B1, and then subtract, and I'm going to use some parentheses to get the order of operations, b1 cubed minus b1. I always click it when I want to reference it. There's my numerator, divided by 3 times, click it, b1 squared minus 1, and my parentheses. Okay, so you can see the formula. It's formatted a little bit difficult to see, but that's what's in this blue box. You want to make sure you get that accurate. And when I hit enter here, it's going to return the value x2, the 1.5 that we computed. But I don't want to keep typing all of that. That's just almost as bad as putting it into a calculator. So what I'm going to do is click the cell where I just typed that formula. Again, move the cursor so that it turns to that cross on the bottom right, and drag it down any number of rows that I want. And what Excel is going to do is it's going to compute using this pattern, using the formula we typed in, except every row it will compute it referencing the cell that's right above it. All right. So this 1.5 was computed referencing the 1. Well, this number is computed referencing the 1.5. All right, so stop and compare that to this table over here. You can see I did some rounding, but that's where I got my x3, my x4, and so on. And notice here, Google Sheets is displaying, I don't know, it looks like 9 decimal places. And starting at x6, the 6th approximation for this solution, the answers weren't changing. So that looks like a 9 decimal place approximation to the value of our solution to that cubic equation, right? So that's how you can use Excel to sort of have the machine do that recursion for you. It keeps your answers accurate, and it's kind of fun. Okay, Excel, you can type in cosine, sine, all of the available functions are there, e to the x, and so on. So good. All right, I hope that's helpful for you as you're doing your Newton's method problems. Thanks for listening.